Hello, 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 everybody. We are back again with another explanation video. This one is going to be for discussion number 3 and chapter 3, adjacent to that. So let me share my screen really quickly and go to the PowerPoint first. Um and then I'm going to briefly I truncated a lot, of course, because there's a lot that goes into this chapter, but I truncated a lot of it just to focus and zero in on the parts that were pertaining to the brain, since the discussion 3 is pertaining to the brain. So let's do this. All right, so neuroscience and behavior. But before we get into the brain is composed of neurons. So we're going to do a little bit about neurons and then shift into the brain. So, first things first. Neurons are cells. So neurons are nerve cells that are found in your body. You have them all throughout your body from your head to your toes. One interesting thing about neurons is that you are literally born with over 100 billion neurons in your brain alone. So neurons are kind of a big deal. So neurons are everywhere, all throughout your body, all throughout your brain. What do they do for us? What they actually do for us is they actually send information back and forth to each other, essentially. So, whenever we want to do something, or whether it's voluntary or involuntary, neurons are communicating back and forth with each other to help us do those things. So, these cells are always active, they're always moving, they're always in motion, sending messages, receiving messages, traveling back and forth. So, the neurons are just doing a lot for us. Virtually everything that you do in your life, whether it be thinking, whether it be moving, anything that you do in your life, neurons are helping you to do that job. So that was neurons in a nutshell. All right. So what is a neuron composed of? So some of you may have seen this before in like biology classes, et cetera, et cetera. But just to break it down a little bit. So neurons are composed of a few different parts. We're not going to go into every single part of a neuron because it's very intricate, but we're just going to go into the major parts of a neuron. So every neuron has what's known as a cell body. So the cell body contains what's known as the nucleus for the neuron. The nucleus, if you remember from way back in the day, is the command center. So it's like the brain of the cell. So the cell body contains the nucleus, which is like where all the information goes. It's like the command center of the neuron. The next part of it is the dendrites. So the dendrites is an extension from the neuron. And what they are is they're like these little branch like structures. And what they do is they receive messages from other neurons and relay them to the cell body so that the cell body can figure out what they want to do with this message. Next part of the neuron is an axon. So an axon is like a tail-like structure that extends on the other end of the neuron from the dendrites. And what that does is it's a traveling mechanism. So what it does is once the message is received by the dendrites, it goes to the cell body, and then once the cell body decides what it wants to do with that message, it then sends that message down through the axon to the next cell. So in between each cell, there's something called a synapse, because none of the cells in our body actually touch each other. Even though they send messages back and forth all day, every day, every moment, every millisecond of the day, they're never actually touching one another. There's like a tiny gap in between each one of them. What ends up happening is your cell, the end of your axon of your cell, what it will do is it will release something called a neurotransmitter. And then neurotransmitters are just chemical messengers that send messages back and forth. Essentially, that's the easiest way to describe them. You might have heard of different neurotransmitters like dopamine, serotonin. You might have heard of those, but there's a ton of them. And what these neurotransmitters do is, since the neurons don't touch each other, what they do is they carry the message from the first neuron across the gap, also known as a synapse, to the next neuron. And that's how that process works. So receives a message from the dendrites, goes to the cell body, travels down the axon, the neurotransmitters are released, they go across the gap or across the synapse, and then they reach to the next neuron, and until the message is fully sent to wherever it needs to go, essentially. Couple other fun facts. All neurons are covered by something called a myelin sheath or myelin. And essentially, what myelin is a fatty substance that helps to insulate the neuron and helps to send messages faster. When we're younger, when we're healthier, we have a lot of myelin covering our neurons, which helps with reaction times. It helps with processing speed. It helps us to just be full and vibrant, essentially. As we grow older and as our body starts to kind of, wither away a little bit, what ends up happening is we are sorry, I just skipped away from the slide. What ends up happening is our myelin is produced less and less, and it starts to become damaged, so to speak. And what that does is it leaves our cells vulnerable to decay, vulnerable to damage, vulnerable to different things. So, what can we do to preserve our myelin? What can we do to keep our cells insulated? There's a couple of things that will be a common refrain throughout the entire textbook. But there's a few different things you could do. So the first thing is to try to eat a relatively healthy and balanced diet that includes things like antioxidants, leafy greens, things like that. The next one is exercise. So try to what they say is the recommended amount of exercise is at least 20 minutes of intense, moderate to intense exercise at least 5 days a week. Doesn't mean you have to be an Olympian, but if you try to get exercise in, try to make sure it's moderate to intense, or at least moderate, and try to do that on a frequent basis throughout your life. That will help. Another thing is trying to abstain or at least moderate indulging in substances that could harm your health. So overuse of drugs, overuse of alcohol, things like that. Try to abstain from that as much as we can. Also, not engaging in other reckless behaviors that are associated with that as well. Um, and then also stimulating our mind. So stimulating our mind constantly. So whether we're learning new things, whether we're reading, whether we're traveling, whether we're taking up new hobbies, as long as our mind is continually being stimulated, that helps to prolong that myelin as long as possible. Doesn't like reverse aging or anything, but it does help us to, preserve ourselves as long as possible. All right. Another fun fact is that there's also another type of cell that is throughout your body, and it's called glial cells. So there's different types of neurons that send messages back and forth, and then there's different types of glial cells. The first fun fact about glial cells is that we already said that there's over 100 billion neurons in our brain alone at birth, and there's trillions of them throughout the rest of your body. But crazy thing about this is that there's even more glial cells in your body than there are neurons. So you're like, whoa, 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 whoa. We have over 100 billion neurons. Where do we have room for these glial cells? But nevertheless, the way that our bodies are designed is that we actually end up having more glial cells than neurons. And what do glial cells do? What they do, long story short, is they help to support our neurons. So if a neuron needs nutrients, a glial cell will give those nutrients. If a neuron needs to be repaired, the glial cell will do that repair. And the list goes on and on and on. So glial cells, they got our neurons back. That was a bad joke. All right. So anyway, all right, so if you wanted to see a visual of what a neuron looks like, this is pretty much just showing exactly what we just said on the last slide. So those little branch-looking things, those are the dendrites. The cell body contains the nucleus, which is a little circular-looking structure. Then we have the axon on the other end, which travels the message down until it's ready to go to the next cell. All right. So now we're going to segue into the brain, which is the main reason why we're here today. So there's a whole bunch to the brain. There's no way that we could cover it in one class period, or even during this, however long this video is going to be. There's no way we could cover the entire thing. You can literally get a doctorate degree and spend your entire life focusing on just one part of the brain. So, and then there's so much about the brain that we haven't even discovered as far as neuroscience has progressed. So, that being said, we're going to try to get into the basic parts of the brain. But even these basic parts are going to feel like a whole lot, but we're going to try our best. All right, so first things first, there are three major overarching divisions of the brain. We got the hindbrain, which is in the back, which is why it's called hind. So hind means back. We got the midbrain, which is up in the middle, which is why it's called mid. Mid means middle. And then we got the forebrain, which is in the front. So forebrain, front. Fore means front, essentially. So the hindbrain, that helps with like the basic things that help you to survive. So it helps with things like breathing, heartbeat, stuff like that. If you don't have your hindbrain, or if their hindbrain is not intact, uh, it's going to be very difficult, if not impossible, for you to survive. One interesting slash fun fact, though, scientists originally thought that if you were born without um any function of your brain, then you would automatically not be able to survive. But there was a child that was born, and I forget what year he was born, but there was a child who was actually born with just the brain stem. And he actually survived for like 10 years. He ended up passing away, unfortunately. But his story pretty much showed that you don't technically, even though you do need a brain, obviously, you don't technically need a brain to survive, which is kind of interesting, kind of cool. All right. So back to the brain discussion. So we got the hindbrain, which is in the back, as we said before, and it contains the most basic functions: heartbeat, breathing, things like that. Then we got the midbrain, which helps primarily with auditory and visual information as well as movement. So knowing where you're going, having a sense of direction to where you're going, being able to balance, things like that. Midbrain helps with all of that, as well as seeing and hearing. So it helps with a few different things, but those are the main things. And then the forebrain is considered to be the highest level of the brain, is found in the front, which is why it's called the forebrain. And it helps with all the complex processes that we engage in. So if we're taking a test, our forebrain is helping us to take that test. If we're trying to plan our vacation for next year, our forebrain is helping us to do those kind of things. So the list goes on and on. All right, so that's the basic stuff. And all of these do more than what I said. I just wanted to give you the basics. All right, so then we got another element of the brain, or another layer of the brain. I told you there's a lot. So the next layer of the brain is called the limbic system. And the limbic system has a few different elements to it, a few different parts to it. We're just going to give a brief snapshot of each one of those. So first, underneath the limbic system, what does it actually do overall? Overall, the limbic system helps with a number of different functions, but some of the primary functions are our motivation, our emotions, our learning, and our memory. Within that, there are certain subsystems that help with those specific things. So, first things first, we have something called the hypothalamus, which is a part of our brain. The hypothalamus helps with a lot of basic functions, like if we ever get hungry or thirsty, the hypothalamus helps with that. If our body is heating up too much or too cold, our hypothalamus will help us to regulate that. Also, our hypothalamus helps us with something called homeostasis, which is our body feeling a sense of calm and our body feeling a sense of being balanced. If we ever feel imbalanced in any kind of way, our hypothalamus is the part of our brain that's telling us about that. Like, meaning that I need to eat right now. I need to go to sleep. I need to drink some water. I need to use the bathroom. Things like that. Your hypothalamus is actually helping your body to not be hungry, not be thirsty, not be too cold, not be too hot. All those things. Hypothalamus is helping with all that. All right. So shout out to our hypothalamus. Next part is our hippocampus. So the hippocampus is actually a part of the brain that helps us with memory. So whenever like let's say you're listening to this lecture right now and you're taking notes and you're retaining it all, absorbing it all, if you were asked questions about this and you're able to answer those questions, your hippocampus is helping you to do that. So it helps you to remember all the information in your life, basically. It helps you remember things like your name, things like what you learned yesterday, things like what your friend wore to her birthday party, all those kind of things. Hippocampus helps you with that. Then last but not least, we have the amygdala. Kind of an ugly name, but hey, amygdala actually helps us with emotions. Not only does it help us to process emotions in ourselves as well as other people, it helps us also to recognize emotions in ourselves and other people. And last but absolutely not least, it helps us to form emotional memories. And it's said that the amygdala is so important that emotional memories can sometimes be even stronger than just regular everyday memories. So that's the limbic system in a nutshell. Then we have our two hemispheres. So now we got a whole nother layer of the brain. So our brain is organized into two hemispheres or halves. Hemisphere means half. So we got the left hemisphere and the right hemisphere. The two hemispheres of our brain are actually connected by this thick bundle of axons called the corpus callosum. So it's connected by this corpus callosum. And what that corpus callosum does is it helps messages to travel back and forth between the two hemispheres of our brain. Without the corpus callosum, it would be like we had two brains in our mind, or in our head, should I say. It would be like we had two brains. Even though we don't have two brains, it all functions as one big brain. Each side of your brain or each hemisphere of your brain kind of does different functions. They both work together for everything that we do, but they have slightly different functions. And that it's vital for that corpus callosum to attach them both to each other so that they can run as smoothly as possible. If they are detached from one another, your brain can still work, it can still process, you can still be just fine, but there will be some issues that you will end up facing inevitably. So we're going to talk a little bit more about that a little bit later. All right, so now we got another layer of the brain. Like, okay, I thought we learned enough, but nope, there's more. And there's even more than what we're going to talk about today, but we're just trying to get into the basics. All right, so then we got lobes of the brain. So it's like, okay, another layer here, another layer here. All right, so within the lobes of the brain, there's four different lobes, and then there's something called the somatosensory cortex, which we'll talk about after we discuss the lobes. All right, so the first thing is our occipital lobe. Our occipital lobe is found in the back of our head, and what it does is it helps us to see, essentially. It helps us to not only recognize what we see, but also to see in general. So if you ever heard the phrase, I got eyes in the back of my head, we all do because our visual processing center is in the back of our head. Also, not so fun fact, that's the reason why if you hit the back of your head long enough or hard enough, should I say, you could actually go blind either temporarily or permanently. So don't try that at home. Wear your helmets, protect yourself. Okay, then we got the parietal lobe. So the parietal lobe is found in like the upper mid part of your brain. And what it does is it helps with a few different things. So like the sense of temperature, sense of pressure, sense of touch, sense of balance. It helps with estimating distances. It helps with a bunch of different things. So let's say that you're driving down the street and you're about to click on your blinker to get over to the next lane. You being able to know that you have enough room to get over without slamming into another car or having another car slam into you, your parietal lobe is helping you with that. So shout out to our parietal lobes. Keep us safe. Then we got the temporal lobe. The temporal lobes are found by your temples. And what they do is they help you to process things that you're hearing as well as to hear. And then we got the frontal lobe. The frontal lobe is found in the front of your brain. And what that does is it helps you with all your complex processes. So thinking, planning, all those kind of things, it's helping you with that. So if I were to give you a pop quiz after this lecture about the brain and you were able to answer the questions correctly, your frontal lobe is actually helping you to do that. It's helping you to process what you're reading, what you're seeing, and come up and integrate information to find answers. All right. Last but not least, we have something called the somatosensory cortex. And the somatosensory cortex is a really cool part of your brain that actually it's like a long strip in your brain essentially. And what it does, let me show you a visual of it. This long strip essentially covers every single part of your body to the point where you can literally touch a singular part of the somatosensory cortex and it will directly affect a certain part of your body. So like there's a literally a part for your finger, there's a part for like your head, there's a part for like your legs. So like if you touch any single part of these, it's going to trigger something within the part of the body that it pertains to. So I just thought that was really cool, kind of interesting. So looks kind of creepy on this picture here, but that's what it is. All right. Other cool fun things about the brain is that our brain is very adaptable. So shout out to our brain. It does a lot for us. So not only does it think and process information and send messages and receive messages and do all this kind of stuff to help us to survive and thrive in this world, our brain also is kind of self-repairing. So if there's any kind of damage that is done to our brain, depending on the extent of the damage and where the damage is done, the other parts of the brain will actually step in to compensate for the part that was lost. So we see this with like stroke victims. We see this with people who have been in bad car accidents, who have had some kind of traumatic brain injury. Depending on the level and the extent of the injury, and 9 times out of 10, your brain is able to compensate for it to the point where sometimes you can't even tell that that part of their brain was damaged because of the rest of the brain has stepped up so much. So yeah, it's pretty cool. Another thing is that our brain is always constantly moving, essentially. So if we learn something new, if we gain new information, our brain constantly rewires itself. It constantly takes in new information and it helps us to retain that information and hold it for the future. All right. So our brain is pretty cool. It's plastic. It changes in function, changes in structure, and it helps us to adapt to this world that we live in, essentially. All right. Other cool things about the brain is there's a lot of influences that can help improve our brain functioning. So the first thing is practice. So if we are doing a certain task and we've been doing it for months, years, days, that part of our brain will become more active than the person who does not do that activity. So for example, let's say that we play the piano. We're a pianist. We play the piano every single day. We practice once a week or twice a week or whatever. The parts of our brain pertaining to doing that fine motor type movement, that part of our brain will be more active than a person who does not play the piano or does not engage in an activity that involves that kind of movement. So our fine motor skills are going to be much stronger than a person who does not heavily use their fine motor skills, essentially. Another cool thing is that our brains can be positively affected by exercise. So we just mentioned exercise when we talked about myelin, and we talked about how exercise can actually help preserve our myelin. If we engage in that moderate to intense exercise a couple days a week, and we do that on a regular basis, it's going to help preserve our youth, preserve our vitality, and help with our myelin. It also helps with our brain. So it actually helps to increase the connections between neurons. It helps us to build new neurons, and it helps us to preserve that myelin that we talked about before. So exercise can definitely help our brain. Other interesting slash fun fact is that culture can also influence our brain. So if you look at individualistic cultures versus collectivistic cultures, they have found that our brains are literally structured and work in different ways based on the culture that we are raised in. So, an example in our textbook, they showed people from individualistic type cultures and people from collectivistic cultures. They showed them a picture of a fish inside water, essentially, and they found that the people from the individualistic type cultures, they would just zero in on the fish in that picture, and the people who are from the collectivistic cultures, they would focus on not just the fish but the environment that the fish was in. So that was kind of really interesting and kind of cool. So it just shows that based on the culture that we are raised in, that's going to show how we process the world, or that's going to influence or shape how we process the world. So it's kind of interesting, kind of cool, kind of intriguing. All right. Last but absolutely not least, we already said that our brain is divided into two hemispheres. We already said that the hemispheres are called halves. We got a left hemisphere, we got a right hemisphere. One thing that we didn't discuss yet is that our left hemisphere actually controls the right side of our body, and our right hemisphere actually controls the left side of our body. We did not mention that yet, but there is a crisscrossing in function of the two hemispheres of our brain. So that's one thing that scientists have found. Another cool slash interesting thing about the hemispheres is that each hemisphere is more dominant in certain things. So, for example, the left hemisphere has been found to be more dominant when it comes to things like verbal processing. The right hemisphere has been found to be more dominant when it comes to like more spatial activities. That being said, both hemispheres actually work together with all functions that we do. So there's not like, oh, that's just the left hemisphere or that's just the right hemisphere. Both hemispheres work together on everything that we do. It's just that one is more dominant than the other. Another cool thing that a lot of people may not know is that when it comes to our brain, there's like a lot of people out there who say, "Oh, humans only use 1% of their brain," or "Humans only use 10% of their brain." That's actually not true. We all use all of our brain at all times, and if we did it, we would have some problems. So, unless there's like brain damage or something else going on, we're all using all of our brains at all times. But here's another cool thing. Another cool thing is that when it comes to the differences between males and females, females have a tendency to use both hemispheres more than males, and I'll just leave that with y'all. All right, so anyway, we're gonna go to our forum and let me go over here so we can talk about the forum. And we are going to go into the instructions and talk about it. All right, so now we are on the chapter 3 discussion. All right, so it says using the concepts that you've learned in chapter 3, describe an everyday activity that you do, such as eating, doing homework, walking, etc., and describe the parts of the brain or the various parts of the brain and how they contribute to that activity. You must include at least three parts of the brain in your explanation. So, the purpose of this assignment is essentially just to go back to what we just talked about and just point out the fact that multiple parts of the brain are always at work when you're doing any given task. So, if you choose homework, if you choose eating, if you choose whatever, just pick out three parts of the brain that pertain to that activity and just show what those things are doing. And then once you're done with that, comment onto your classmates. Make sure that your comments are show they reflect thought and they reflect critical analysis of whatever your classmate said. Once you do that, you'll be all set. So just pick an activity, one activity, it could be any activity in the world that you do, and show at least three parts of the brain that contribute to the activity and talk about what each of those parts is doing while you're doing the activity. So hopefully that helps. All right. So that is chapter 3. The explanation has concluded, and let's do another week. So I'll talk to you guys and I'll post this on our YouTube.